Okay, so we'll be doing Codeforces Round 1057 Div 2 today. 28,000 people have registered. Okay, let's go straight into it. I'm just gonna be trying for the first half an hour and we'll try to solve at least two problems. There are n apple trees arranged in a circle. Each tree bears exactly one apple, and the beauty of the apple on the ith tree is given by bi. Start at front of the tree one to either eat the apple or skip it. And from tree n, you move back to tree one. Of course, you are in a circle that you would do that. However, you have a special condition. You may only eat an apple if its beauty is strictly greater than the beauty of the last apple you ate. That you are not allowed. You are allowed to skip an apple when you first encounter it. You can choose to eat it later on a subsequent cycle. Task to determine the maximum number of apples you can eat if you make optimal decisions on when to eat or skip each apple. T test cases N B1 Bn. Ideally, what we would do is we would, if we really want to optimize the maximum number of apples that you can eat, uh, and not optimize the number of rounds we make, then I think we can do that by. And what do we have to output? Maximum number of apples. So will there ever be a case where we are not able to like eat all of the apples? Of course, there is a case here, and you can see that you can either choose to eat 1, 2, 3. So 1, 2, strictly greater. Strictly greater. Okay, so you cannot eat apples of same beauty. So the answer is for int I is equal to 0, I less than n, I plus plus. You can store that in a set and just print out the s dot insert b of I, and even we can my first go. I'm not taking a lot of test cases. I might be wrong, and we fucked up. Where did we fuck up? Why did it not print the size? Okay, weird. Run it again. I did not expect anything. Thank you, ChatGPT. We're given three non-negative integers x, y, and z. Um, um, Determine whether there exist three non-negative integers a, b, and c satisfying the following three conditions. So we have to find a, b, and c, where a and b is x, b and c is y, and a and c is z. These things change. So to determine a, so and means when there are two ones we print a one, and if there is 1 0. So and ChatGPT could solve it in seconds. And since we only have to print yes or no, let's look at some examples. That was easy. Okay, so where would this never be possible? When would this not be possible? Look at some other questions. Okay, let's do some operations, bitwise operations between x and y. So let's say x and y. I have no idea what to do here. So let's just do this. So x and y is basically a and b and b and c. Does that make any sense? So this should be equivalent to a and c, right? Which is z. So x and y should be equal to c. Z, sorry. And similarly, when we do um nah, this is not the correct way, guys. Guys, this is A and C, which is C and B, because we're forgetting the B bits, right? Okay. Now if we do X and Z, that's A and B and C. So that's A into Y. A and X. And I don't think we are getting anywhere with these. So let's just do an OR maybe. So the OR of these two would be um this is B and A or C, which doesn't make any sense because we just have this equation right here which doesn't really do anything. Because A or C is nothing. And I'm stuck. And I don't have much time. Let's move on to the next problem, which would be much more difficult as I think of it. Okay, let's look at another example. A is 7, B is 3, C is 22, satisfies the condition of 7 and 3. Okay, let's think of simple terms. Let's just make sure the one number is 1 1 1 1 1 and y is, let's say, 7 and 3 is equal to 3, of course. Mhm. What about break x, y, z into bits? And since they are like ands of two numbers, we can look at, let's say x is 1010, right? We can can make x using any two numbers where here there can be anything. Oh no, there should be one. It can be anything for this one. Uh, okay, I think I've figured it out. So the only way it cannot happen ever is when, since A and B make up X, and obviously A would be used in one of the other ones as well, right? So any bit um, that's set in X, so let's say it's 1, then A and B both should have that bit set, and then so should, and if like Z has that bit unset, um, that's possible, right? Because ah, that's not possible because now that's possible because C cannot have that bit set, and then that would work. Let's say some bit is not set in X. That does not restrict anyone, anything. Well, let's look at another test case. Oh no. When we take and, we're taking the common bits in both of them, right? So when someone's and is this, and and is this. So covering this means we should be able to find a number b such that x and y is equal to z and b. So covering over that, that will never be possible if z has a bit unset where x and y doesn't. So the way we solve it is um, int let's say x and y equals to x and y. I don't know. I'll do that. Similarly, y and z and x and z. So I think you get the point. We can do that.